Hello everyone. Let's look into another kind of impact that the crosstalk delta delay can have on timing. So in the past videos we have seen that the aggressors and the victims are switching in the opposite directions. We'll look into a scenario where the aggressors and victims are switching in the same direction. Let's bring the circuit first. So we have this victim net with us. We have the victim driver, victim load, and the victim net, and we have the aggressor driver, aggressor load, and the aggressor net with us. So it's the same scenario that we had before, and the coupling capacitances between the aggressors and the victim. Okay, the scenario still remains the same. Let's remove all the names from there and keep it very simple. So these are the grounded capacitances that we have. This is the mutual capacitance that we have, and the aggressor and the victim. Okay, let's move on with this. So in the previous scenarios, whatever we did, we had a case where the aggressor and the victim were switching in opposite directions. Okay, in this case we'll be looking into a scenario. You might also go you might want to go back into the previous lectures and see what we did. In that case you will see that this one and this one were actually switching in opposite directions. For example, if this is to switch from logic 1 to logic 0, the victim is to switch from logic 0 to logic 1, and vice versa. It did happen in the past videos. Let's try to look into a case where the victims and the aggressors switch in the same direction. Okay, so this is the input signal for the aggressor. This is for the victim, and the expected outputs for this particular scenario is the aggressor output will switch from logic 0 to logic 1, and the victim will also switch from logic 0 to logic 1. So typically if you see, the delay between the delay of this particular cell is from this center point to this center point. Okay, now we will see how this delay gets modified because of this particular switching aggressor in the same direction. And also in the past cases we have always seen that the delay always increased, and that's what impacted the setup timing analysis. In this case things will be a bit different. So now let's try to analyze this first. What is happening over here? So let's say these are the, again we'll take the example of the bucket and the water, because that's a very fair example, and that has been a consistent example that we have been taking in the past videos. So let's take an example of a bucket. Let's say this bucket has to be filled up, and this particular tap is open. So when this particular tap is open, this bucket gets filling from 0 to 1 with charges. So basically this capacitors gets filled with charges, and the charge makes the voltage across the capacitors rise from 0 to 1. Okay, that's how you determine the logic 1 and logic 0 potentials over here. So as this thing is filling this particular buckets from 0 to 1, there's finite amount of time required for this tap to fill these buckets, and that time is denoted by the slew, the transition of this particular signal. So let's say t picoseconds. So this tap takes t picoseconds to fill up this particular buckets with water. Now logically, if instead of one tap, if there were two taps over here, then logically if you see, the buckets would have been filled a bit faster. That is quite true, that is quite obvious. Similar thing is happening over here, only the difference is the bucket is the tap is not somewhere over here, but the tap is over here, and this tap is open, and you have a bucket over here which is leaky. This bucket is leaking over here, and as a result of that, while this tap is open and trying to fill this bucket, this tap is also simultaneously open, and it is also trying to fill this buckets through this leaky bucket which has a hole over here. So as a result of that, you see that this particular buckets gets filled faster. Okay, that's what is being represented over here. You have this particular tap open. This particular tap is trying to fill its own buckets, its own grounded capacitors, but also there is a leakage, there is a leaky bucket over here, and as a result of that, this tap also puts some water over here and tries to fill this bucket simultaneously along with this particular tap. So now when two taps are open and they're filling these buckets, this particular transition from 0 to 1 will be a bit fast because the buckets are getting filled a bit fast. Okay, so as a result of that, what you will see is you will see a shift in the transition, but not in the worst side, but in the best side. See, if you see the transition in the diagram has become from this to this, so transition has become better. So we have always studied that better transition, the sharper the transition, the better the circuit. We have always studied about that. But do we know if it does it has any impact on the existing circuit or not? Do we have to analyze that what this transition, the variation, the transition that you see over here, switching from this transition to this transition, how can that impact your overall circuit timing? We have to now study that. We have to now understand that. Before moving into that, we have to understand some basic things, what's happening over here. So what's happening, what was happening was that initially you were somewhere over here. This tap was trying to fill this empty bucket, okay, and then suddenly we have this leaky bucket, and this tap is open simultaneously when this tap was open, and as a result of that, this tap contributes to the amount of water that is getting filled in this particular bucket, and hence this bucket fills and gets filled faster, and the impact is shown by the transition time that you see, that you see a sharper transition time. And also this also explains the concept of timing windows, where these two taps are open at the same time. That means that the windows are overlapping, the timing windows are overlapping. Okay, so now if you actually want to look how this particular thing impacts your timing, let's take this particular cell out. We'll take this particular cell out of this circuit. Okay, let's bring it somewhere over here and see what is happening with this particular cell with and without this particular transition. So initially this particular cell has got an input transition of this, which is this, and an output transition of this, which was not this but before this one. And as a result of that, the delay of this particular cell was D. Okay, before that the delay was D. Now when you see a crosstalk impacted victim over here, as a result of that, now see what happens to the delay of the cell. So this particular inverter had got an input of this, but output has got a better transition. As a result of that, this particular inverter is faster. So what can impact a faster, how can the fast varying of this particular delay can impact the timing? Basically, we always want things to be very fast because setup timing we know it's because of the huge delays, and this is actually helping your setup timing. That is true, but there is another way to look into it, that this particular thing impacts some other kind of timing. We'll look into that in some time from now, but let's look how it is different from the setup timing that we saw. So if you look into this circuit, and if you looked into the previous circuit that we had been discussing, in this case the aggressor and the victim were switching in opposite directions. In the previous cases, the aggressor was switching in this direction and the victim was switching in this direction. As a result of that, you see this, you saw these waveforms over here, and you saw a bump over here, a glitch bump over here. And as a result of that, previously, if you saw the delay of this particular inverter, if the previous delay was D, the delay after the crosstalk was D plus X. Basically the delay of this particular cell increased, in contrast to what we saw over here. In this case, the delay of this particular cell has decreased. So we have seen the impact of this one on setup timing. So one might also argue that this kind of scenario will help the setup timing. Yes, that is true, it will help setup timing, but there is another kind of timing which is the hold timing closure that we see, will be looking in some time from now. There is a hold timing in which you consider all the fast delays. So there we prefer the cells to be delayed a bit. But if this kind of scenario occurs, it will have affect your hold timing. How it will affect your hold timing? Let's try to look into the hold timing and how this particular scenario impacts your hold timing in the next video. Thank you.